Qualcomm Technologies and Nokia Bell Labs are working together to unlock the full potential of wireless AI, creating a wireless system that learns and improves over time across different devices, networks, and technologies. By combining the power of AI with wireless systems, we're opening the door to a new era of smarter connectivity. To understand how AI can improve our experience, let's examine how it impacts one of the most essential tools in optimizing wireless systems, channel state feedback. Channel state feedback helps the network figure out the best way to send data to your device. As wireless conditions change, so does the optimal direction a transmission takes from the network to the device. Channel state feedback, however, allows the network to find those ideal avenues by generating precise beams. Using AI, we can dramatically improve how the system tracks channel state feedback, making the network and devices smarter and more efficient. Implementing AI effectively into wireless communications, however, is a complex matter. In even the simplest wireless system, there is a network and a device, and both utilize their own AI models. Those models need to cooperate. That's the heart of Qualcomm and Nokia's joint research, getting AI in the network and devices to work together to amplify their benefits. To test their AI-powered solution, Qualcomm and Nokia Bell Labs set up a 5G test network using cutting-edge equipment and mobile devices powered by Qualcomm 5G modem RF.
So we begin with AI models, which are trained with a shared data set. We use a technique called sequential learning, where the model in the network device is trained first, and then the model in the mobile device is trained. We use a shared data set to make sure that they speak the same language as they learn, without requiring different companies to share detailed information about their implementation. After the AI models are trained, we put them into action. The network device sends pilot signals down to the mobile device. The mobile device feeds that information into its AI model to get a feedback signal, which is sent back up to the network device. The network device uses its AI model to decode that feedback and then use it to determine optimal beam patterns to focus the signal energy right to that particular mobile user.
We've been very pleased with the results so far. In our tests, we found sequential training has substantially improved downlink throughput compared to traditional approaches. This shows just how much AI can enhance the performance of wireless networks. Since the collaboration between Qualcomm and Bell Lab, we have expanded our scope in terms of research and testing. We have bring our models in more tested areas compared to last year. So this year, our primary goals will be ensuring not just the interoperability, but also the scalability of the AI models. We want to make sure it can work in different environments. We compare the performance of model, which is trained with data from various locations, against the performance of hyperlocal models trained with specific cell site data. In every case, the AI system performed consistently.
When we tested the models in situations where they hadn't been specifically trained for, we found that the system still worked well. So this means that AI models don't need to be trained for every specific site, which makes it much easier to deploy and use. For example, it would work just as well in a busy urban center as it would in a quiet suburban neighborhood.
Additionally, we tested a synthesized model trained based on simulated channels in outdoor and indoor OTA environments. Although slightly worse than the OTA models, the synthesized model still outperforms Type 1 with substantial gain.
In the end, the AI-driven approach we used proved to be simple, powerful, and highly scalable.
As we continue our journey toward building smarter, AI-native wireless systems, these innovations will pave the way for the next generation of wireless technology. Stay tuned for more as we continue to push the boundaries of what's possible.